So tonight we're going to be looking at how to implement a fireworks simulation. It's one of those simple but very appealing applications. I remember loving the screensavers when I was a kid, where there would be these little rockets flying up and exploding, and it would be super pretty. So I'm going to see how close to that we can get today. And I mean, let's just jump straight into it, shall we? So, for the people who've been here before, you can probably guess which language. Hey, The Real, welcome back to the stream. You can probably guess how which language I'm going to choose for this. At least you can now. If you couldn't before, let's do all the init that we usually do. npm init, also with a bunch of yeses here. Let's go. We're also going to need like the same graphical stuff we do every time. Hey Jens, welcome back to the stream. Fortran, that would be awesome. Let's just jump straight to circles. I think that has what we need, because we need this file. Give it here. HTML, boom, put it in. Nice. And we also need to get the context. So let's just do, whoops. Let's just do a new index.ts and let's set this one compiling in the background. Let's get the context here. Good. And so now if I open up a new tab over here, one over here, I should be able to drag this over. Yes, great. And everything just fits. Boom, perfect. What do we need to do? Well, first let's make sure we can draw on the thing. I was gonna draw like a circle, but that was problematic, wasn't it? Fill rect is an easy command because it can start somewhere and then we should be able to see it immediately. Do we need to set the color? .fill color, no, fill style, yeah. And let's just make it red because it's easy to see. Red should be fine. Let's see. Yeah, and we have a red thing. Why is this not snapping? Good. From scratch. We're building the graphical library from scratch. Yeah, good. So we have a thing now. Already we are so far. So let's start by drawing. Well, so a fireworks system like this is based on particle physics, is what it's called. So we first probably should implement particles and see that they behave how we want them. And a particle is simply something that has no mass. So it has a position. So it has private x, which is a number, and a y. I did something. I don't know what I did, but it was wrong. It has an x and a y position. It also has a velocity on both the x, let's just call it vel x, and velocity y, which means it can move through space. So let's add a constructor so it doesn't error anymore. Do we need to initialize these at different positions? We might actually want to do that. We might also want to initialize them with different velocities. Okay. Well, never mind. Let's just put all of it in the constructor. So we have control over it. We can always move it out later if we don't need it. So now we can initialize the things. It also has an update method, which takes how much time has passed since the last time we calculated physics. Maybe introduce a vector abstraction. Maybe. Let's do that later, maybe. Yeah, let's do that later. So the dt simply says x plus equals velocity x times how much time has passed since we updated last. And the same for the other, for the y coordinate. Okay. So now we should be, it also should be able to draw itself. So let's just add that. Draw with the G, which is a canvas context. What is it called? 2D something. Rendering context 2D. Yes. G.draw rect. So really these should be very small, I guess. And really they shouldn't be rectangles, they should be circles. How do we draw a circle again? Circle here, it's the arch thing. Where's draw? Draw. There. Yeah, it's all of this. So let's put that in. But it will be very small. Its radius will be like, well, the radius would be 1, I guess. On the position, that's okay. That's all fine. Yeah, let's see if we can draw this. Oh, we also need the game loop, right? To have it update regularly. We might as well steal that. We have a draw and a game loop, and it starts. Boom. There's going to be no controls in this game because it's a simulation. So we clear the rectangle. That seems fine. Can I set the background color? Background. No, I cannot. So probably after we clear it, maybe instead of clearing it, we actually should just fill the rectangle with the black color, because I want the background to be black, obviously, so we can easier see the fireworks. Boom. Then let's set it to some other color so we can see our particle. Let's make a particle. Particles, it's just an array, let's say, of particle here. And then we can say particles dot for each draw x point to x dot draw on G. Whoops. It's not called G, it's called CTX. Okay, and let's just put one in there from the start at position 10, 10 with velocity 1, 1. Now, that's just to have some movement in the picture at all. We don't have this, but we have particles. We have update. Let's make a function for that. Function update here, where we say particles dot for each x dot update. Like that. We also need this though to take the time since we last updated physics. So we need to calculate that down here. We can do that by pulling out the last before, which will start by being just nothing, I guess. And then update would be last before, would be before minus last before. And then here we can set it to whatever its value is. I guess that doesn't quite work. We can just set it down here. That works too. The point is just that we need to transfer the last before outside of its scope, or the before outside of the scope. So first time this will fail, obviously, because this will have like a crazy low value, so it would send it flying off. Yeah, so that should be fine. This is in milliseconds though, and we might want our physics to work on a second level. So we might need to divide it by 1,000. So now it updates it by how many, like by a fraction of a second. So we can define how many pixels a second each pixel should move. So this would be 1 pixel a second in each direction, which is probably way, way, way too small. Let's set it to 10 pixels per second going downwards towards this direction. And that should be it. It's black. That's one of the things we wanted. It's looking like it's not drawing it, which is a little bit disconcerting. What if we start by not updating it so that it can't have just flown off before we saw it. Okay, it's not there. I think circle of radius 1 is too small. Let's increase it, although that would pain me if that's the case. We have the fill style, but it's not being filled, it's being stroked. So probably, yeah, so that's better. So maybe we can do it with 1 even. It's there. There is a very small red thingy on the screen here. Let's start updating it. Yeah, and now we can see it moving too. So it is there. It's also hollow, and I want it to be definitely be filled. Fill. And then this should be fill style again. So now it's a little easier to see maybe. I don't know if you can see it on the stream. I can see it here. Should we make it a little bit bigger? Probably. There it is. So we have it there. It's visible on the stream. Good, thanks. What we also have for particles is they have an acceleration, usually. So the acceleration changes the velocity in the same way that the velocity changes the position. So we just add that here. The acceleration is interesting because then we can go down here and we can actually set that there's a 9.82 second downwards acceleration and no sideways acceleration. So that will make it have gravity, right? It will slowly fall towards the ground more and more aggressively. I don't know if that's visible there. I think it's more visible if we set it in a negative y direction. So if we set it going upwards, then you'll see that gravity quickly grabs a hold of it and starts pulling it down. So that's pretty cool. Also now I'm assuming that 1 pixel is 1 meter. I guess that's okay. That's probably fine. Yeah, so we have these pixels now. Something I want to just try is to make a circle of them explode like on the middle of the screen. So let's just make a loop. Less than, let's say 20 for just for a start. And then we need to place them at different, or they need to be placed in the same location. So we say new particle, well we say particles dot push, new particle. And then we want, the position should be the same. It should be the bounds dot width divided by 2 and height divided by 2. And the velocity then should be different in all the directions. So we need to have, what's that? Is it sinus, cosine? Math dot sine of I times divided by 180 comma math dot cosine. We figured this out last time, I feel like, or like a while ago, but I forgot it. 0 in the acceleration to the sides, 0.82. So now will this send 20 particles flying in different directions? Let's see. Yeah, they didn't have very much speed, so they need like a 10 pixel per second speed. Did that not work? That didn't work at all. It should be divided by 19 so that it's between 1 and 180 should be pi. Oh, right. Right. Why not 20? Because 19 is the maximum value. Divided by math, the pi. Yeah, you're completely right. Well, it's not quite exploding in the way that I intended it to. I divided by 19, multiplied by pi. That's closer. That's definitely closer, but I feel like it's only half a circle. Kind of. So we want them to be actually, maybe I just want them to be random. No, I want them to be random within a circle, is what I want them to be. So let's calculate two random values in a circle. Vx, Vy, which are both numbers. I probably need to tell it that because it's TypeScript and it's a bit picky. Do Vx equals math.random. Vy equals math.random. While, so what would be the aperture? So it needs to be round, so I need to say 0.5 would be the center and 0.5 would also be the radius. So I need to check that the distance between the point that we've selected and 0.5 is less than 0.5. While Vx, so that will be the hypot of Vx minus 0.5 and Vy minus 0.5 is greater than 0.5. Is it not hypot? Oh, I'm on the wrong version of TypeScript. Here. Hypot? Yes, good. So now we've selected two random numbers that fall within a circle at least. So that should be good. Let's see. See, that's a random sort of circle, and that's fine. I'm okay with that. They don't have enough speed. I want them to go a lot faster. Yeah, okay, and I also want them to also have negative possible numbers. So maybe we should make these binomials instead. And then I guess we actually don't need this check because binomials fall sort of in a circle by themselves, don't they? Interesting. I guess some of them are still a little, maybe we should still have the check just to make sure none of them are too big. How do we want the, well, now it should be 0. No, that can't be. So they're always positive in both directions now, it feels like, which is not good. Oh, because we subtract something, but now the center is 0. Okay, so 100 is way too much for the speed, I guess. Yeah, something like that seems more likely. And let's increase it to like 40. Maybe I would like it to be a little more spherical. Can I do, if I increase this to like a lot, it should be fairly spherical, which it actually is. Is 100 not enough? Do we need 150? How much to get a near perfect circle? That's pretty good. That feels good. So that looks sort of like our fireworks explosion. I guess they should still be faster though. Yeah. I'm also going to give them a not a fuse, but a material, a glow time. Which is a number, and glow. And every time we update them, we also subtract the time, the thing from the glow time. And if the glow time is less than 0, then we kill them. So we have a function called isGlowing. IsVisible, I guess. And isVisible just returns the glow time right now. Glow time greater than 0. And so down here we give these a glow time of 2 seconds. Boom. Now we need to remove them once their glow time is up. So we say particles equals particles dot filter. The ones that x dot is visible. So now it will filter out all of the particles that are not visible. So after 2 seconds, they should all disappear, and that's maybe a little bit aggressive to have them all just disappear at the same time. So I am gonna scale their color by their glow time, how much glow time they have left. That's gonna be interesting. First of all, that means we need different colors. Private color, which is a, how do I scale a color? We need to make a color library, I think. Yeah, let's make a color class. So a color consists of 3 components. It consists of the private red, which is a number, the private green, which is a number, and the private blue, which is a number. Good. And so we need to have some way to represent this. Can we just set color to a comma separated list? I think we can actually. So set graphics, something like this, which just takes the graphics canvas to the context thing. It's just scale transparency. Yes, that seems actually to be easier. We still need a color though, so that would be a string then in this case, I guess. How do we define transparency? Is it just adding 2 things? We still need to... I still don't know actually how to map that. CTA, why is it using CTX and not G? Bad. G.set fill style here equals, so can we just say this dot color plus, and then we need transparency maybe at the end of this. Let's try with AA just to see if it wants to do anything for us. And then we define this as a hex instead. It does seem to have made it a little more transparent. So then we just need to make it into hex. That should be fairly easy. Glow time. Well, I mean, we need the initial glow time also. Init glow time, so we can scale it. Glow time, this.glow time equals initial glow time. Private glow time is a number. And so now what we say is we say glow time divided by initial glow time multiplied by 255, which is the maximum number of transparency values. And then we toString them with 16 to get them into hex. That didn't seem to work. Let me just print this expression to see what we're actually getting. Here, FF, FA, it has a lot of dots in it. Wait, yeah, so it did scale them all the way down. It just seemed to do so over a long time. Why is it still scaling them down now, for instance? Glow time greater than 0, yeah. This divided by the initial glow time, multiplied by 255. Yeah, that's good. Let's round it down. Here, so that we get an integer kind of value. Yeah, damn, it just jumped in the end. I mean, it looked so good, and then it quickly flashed, and then it, yeah, didn't look good. Why did it flash though? Because it just said F. So we need it to actually be, can I specify how many? No, I cannot. Darn. Okay. Oh, but it does have a pad left, doesn't it? What was it called? Pad left? Pad start. That's fine. And what do I give it to? With 0. And then we need to find out what version of this we want. Is this good? Yeah. Okay. Yeah, and that worked. Great. And hi. Cool. That's pretty cool. So right now we have it be a linear scale. I'm thinking maybe we'd want it to be more of an S-curve. There's a formula for that, but I don't remember it. We have the fireworks though, that's really cool. So if we have an explosion here, we need to put this into a function so we can spawn explosion. Function spawn explosion. And I'm fairly certain that's gonna wanna take a position as its input. So right now, we're just calling it with these two inputs, but it should really take an X and a Y. X number, Y number. Boom. So that shouldn't have changed anything, and it doesn't seem like it has. Good, so now we can spawn an explosion at a position. So now we need to fire up a rocket, I feel like. So a rocket. Really, a rocket is also a particle, but it explodes. And it also, well, I guess it has a glow time to it. Yeah, and a color. I mean, we could just make it as a particle, but with a specific death effect kind of thing. So on, well, I mean, yeah, okay. Let's just put it here. Private rocket, Boolean. Because then here, if glow time is less than or equal to 0, then spawn an explosion at this current location. This dot X and this dot Y. So yeah, these are then not rockets, because that would fill up the screen very quickly with explosions. So now we need to spawn a rocket. So we can say new particle with position. It should have just, let's just say 100 on the x-axis. I'm trying to hit a point down here, right over the C in console. Bounds dot width, no, height. Started at the bottom, that's fine. Its velocity should be a little bit on the x or y axis, but that doesn't really matter. Let's set it to 5. Let's set the velocity y to be something low, and then the acceleration on x would be basically nothing, but the acceleration on the y would be negative a lot because it's firing out stuff. Negative 40, 70, something like, no, 40. Let's not go crazy the first time. How much time does it have to fly up? 2 seconds seem fine. And the color this time would be yellow. So let's see if I can hit a sort of a yellow. FFCC00 seems good. And it is a rocket. So now let's see if we have a, let's see if we have a rocket. Yeah, I mean, we do have, we also wait, why did it stop though doing it? If this dot is rocket, and glow time expires, where's my rocket? Hello, rocket. Oh, it seems like it's died because all of the particles, I think. Yeah, it seems very dead. I can't even close the browser. Yeah, exactly. Yeah, and that was what I was wondering why it didn't die. So we have the rocket, and then it spawns an explosion. 40 seems like it's not enough. What is actually the velocity of a rocket on its way to upwards? So it's a little bit flipped to the side, that seems fine. And it goes faster and faster, that also seems fine. It's a little bit, yeah, I think the curve thing is what, boom, it accelerates too much, around 28 kilometers per second at peak. Really? That's like a lot higher than this. Like a lot higher. Let's make it 70 and then give it 3 seconds instead. That seems good. It hit around the middle. For space rockets, yeah, okay. How about for New Year's rockets? Oh, tea is great. Yeah, so I would like to set a rocket going. Let's make a function for the rocket. Here was. Function. Hi Tarkus Bane, welcome back to the stream. That's the second biggest cup I've ever seen. It's a great cup, I love it. I bought it in New York and I wish I'd bought a lot more. But I didn't have any space in my luggage. Yeah, so where do we want to give parameters for where to spawn it? It's not really important, really, where they spawn, because it just needs to be a bit random. So we have them all be yellow when they fire up. Also, that yellow sort of bothers me a little bit, but we're not going to worry about that. They have the same sort of speed. Do we want them to, I want to actually experiment a bit with whether we can make it sort of do a curve by adding some, it has 5 velocity now, so if I set -5 as its acceleration on the x-axis, it should curve, I think. it didn't curve at all. Interesting. What if I set this to 15? It did curve a little bit, but the point is it's gonna shoot fairly straight up very quickly. Like even if I fire 25, it's gonna, the upwards trajectory is gonna win every time. Unless I set the acceleration to be very big. Yeah, so that it's very hard to fight these 70. Yeah, I guess it doesn't really matter to try and make it curve. That's not important. So let's say that we want this multiplied by a binomial. Here, minus math.random. So now it'll fly in random directions. The yellow is fine, the acceleration is sort of fine. The 3 is 3 seconds, and true is they're all rockets, that's fine. Oh yeah, and instead of just spawning them at 100, we'll say math.random multiplied by the bounds dot width. Now it should spawn at a random place. It's flying straight up, which I definitely don't like. Oh, wait, why was it flying straight up? Oh, it just seems like it's flying straight up because there is no acceleration on the other thing, so maybe this should be 25 instead. Let's see, how off can we make it seem? Not very off. Well, okay, these people are firing their fireworks very straight into the sky. That's fine. So we have the rockets. Yeah, I want to set this on an interval. Set interval here. The handler would be just spawn a rocket, and the interval would be every second. So right now no argument. So right now it should run on an interval here, so we get rockets all the time. And we can sort of, it's a bit more alive this way, not just a static black screen. But YOLO. Yeah, that's the safest way. Do you have drag on the velocity? I have, on all of the rockets or all of the particles that come out of the rocket, I have gravity, but I don't have drag on anything. Only the gravity that does the trick. I think this looks pretty good. I mean, it's a little too staticky colory, and they also don't fly. I want them to fly, you know, a little bit more all over, maybe the top 70% of the screen. So we need this to also be sort of more varied. So 3, well, we'd want it to be, well, we first need to figure out what the top is. What about 4? Start firing. 4 is the top, actually, very accurately 4. That's good. So we want 3 to be the sort of center, and then we want it to be plus minus 1. So that's actually just 3 plus binomial. That should be it. Isn't that what makes them fly in the arc? It could have been, I can set their initial velocity and I can set a constant acceleration. So that way I figured I can make them do like a turn upwards, but I can't make them like bend all the way. I guess well, yeah, not with constant acceleration. I don't think I can do that, but I might not be realizing how. Yeah, so this looks pretty good. Lots of fireworks going off. Let's say we don't want them on the very edges. So let's just subtract like 20 pixels, no, 40 from each side, and then add the 20. So now they never spawn all the way out there. They just, I mean, at least 20 pixels in. That's still, see, that's still too far out. Maybe we should do -100 and then +50, just to have 50 pixels in either side where they're not going to fire from. Can you make a sideways accelerate? Yes, I can. This one will be sideways. How do you want to, what do you want to test? What should I set it to? They look pretty. I like it. Something. Okay. 25. So now they all have they will all start going this way more and more as they fly. Over here. But it doesn't really give us arches, it just makes things... The problem we have is that this one is just way too big to actually... It overshadows this one no matter what we set it to, basically. I want to give them colors. More fun colors. Oh, I also wanted the thing to be on an arch. How do we do the arch things? That's sort of also it, yeah. So that goes from 0 to 1. Okay. And it clamps it. Okay. XX3 minus, that's probably the one I wanted. Smooth step. So it takes a floor, a start. No, why would it do that? What is edge 1 and edge 2? Why doesn't it just take a number? X. Yeah, why doesn't it just take a number? X, which is a number, return this thing of the number. Yeah. And so smooth step would be the function here. That's it, right? Fire. I mean, I don't see much difference, but I'm guessing it's probably correct. This is perfect. This is fine. I want to give them colors now. Like just looking at red is a bit monochrome. So let's make them have colors. That means our spawn explosion should take a color, which is a string. That means up here we should define valid colors. Const colors. What are some good colors? We have red, of course. Then we have, what about maybe some green? We might even want some blue in there. But I think if we just do the trivial blue, it'll be hard to see against this background because it's quite dark. Let's have some pink. What would pink be? FF00. What does pink have more of? Is it? This is purple and it's dark, right? So we need like 77, something like that. White. White. I guess we could have white. That would be this one. What else was there? Purple. Yeah, we have purple. Black. Black would be invisible though. That would be a waste of processing power. We could have golden rain or whatever it's called, the one that falls for a long time. But I guess then we actually need to specify more than just the color. So this would be the same yellow. Okay, these are some colors. We can add more later. Spawn explosion, and these take a random element from this set. And random element is something we need to implement. Function random element from an array equals some array of elements for t. Just return R on index math dot, well, we need to round down whatever we get from math at random multiplied by R dot length, like this. So now we should have randomly colored fireworks. These are not randomly colored because we're not using the color, I'm guessing. Yeah. No. Do we? There. That was pretty close. Now we should have it. Random colors. Yellow, red, purpley, green, yellow. Yes! Lots of nice colors. So let's implement tails. We soon need, yeah, okay. So private tail, boolean. And so what tail should do is just have another particle, yeah, spawn. Yeah. So every time we call update, if tail, then we should say particles dot push a new particle with the current position this dot y. What do we want the velocity to be? Basically nothing, right? That's the whole point. 0 for velocity, 0 for acceleration. Maybe we want these to have gravity 2. I'm not sure yet. We'll test it out. Their lifetime will be just 1 second. It doesn't really matter. And their color should be our color. And they are not rockets, otherwise that will be crazy. And they don't have tails themselves. Otherwise we get some crazy recursion. Let's make the rockets at least have tails for a beginning here. False and false. So the rockets do have tails now. Same velocity direction, but slightly less speed. That I considered that. You might be right in that. Let's just see how it looks. Like it's a lot too long. Like 0.3 is probably better. It's a little bit, I'm running at 30 frames per second, and that seems to make these, the ones that are very quick, you can actually see the room in between, and that's not great. But I think if we increase this, that should be a lot harder to see. Yeah, maybe these things are too big now. Maybe we can set them back down to a 1 in size. Because there are so many of them now. Maybe that makes them easy enough to see. Want to try it out? That does not seem smaller any bit. Did it get smaller? Did I move the wrong thing? Oh, these are smaller. Yeah. That seems pretty good. And then when it's lagging, of course, you can see the trails. But other than that, I think this is better. What do you guys think? Do they need to be moving? Let's see what it looks like if they're moving. This divided by, let's give them just 1/10 of our velocity. I mean, there's actually no reason we don't spawn even more of them. Why every second? Why not every half second? Yeah, so we also wanted rockets that had a tail sometimes. Or I mean, yeah, rocket explosions that had a tail sometimes. So we could just say math.random is less than, oh, we need to make it consistent on the whole explosion, not just some of the particles in the explosion. That would be awkward. Tail equals math.random is less than 0.1. So in 10% of the cases, we'll get a tail now. on the explosion. No tail, no tail, no tail. That's a tail. That looks really nice, actually. I think they should all have tails, and I think the tail length should just be different. So what we are going to do instead is we're going to say if tail is greater than 0, and then tail is going to represent the tail length. And then that means these just have 0 tail length. So now we can say tail should be a number, which is the lifetime of the tail. In this case, it was 0.3. And in this case down here, it should be instead this number. And I think just math at random. It seems to be lagging a bit now. Let's decrease the rate of fireworks so we can focus on the ones that we have. Okay, so we want this to not just have one color, but 2 colors. Where do we spawn the explosion? We spawn the explosion with a color. So that will be the primary color. And then we'll select a secondary color, I guess, on the fly. Random element from colors. And then there will be a chance to do the second color. And let's say that that chance is 40%. So now they should all have 2 colors. Did I pick bad fireworks colors? Should this actually be something brighter? Or darker? Darker probably, right? Like 8.8. And this one should probably be CDE. I think we should put on some effect on this. And that's definitely gonna make this a lot more intensive. So maybe we should remove the tail. Well, okay, let's try to do an effect called bloom, because that will make it look like these are bright and shining and stuff. So I think we should remove the tail just to have enough headroom in the performance to actually do this. So let's do false, and that's a quick way to disable some code. So bloom is a graphics effect. So what we need to do is we need to take the image that we're generating from this, then we need to scale it down, do a Gaussian blur, scale it back up again and draw it additively on top of this, if that makes any sense. So draw instead should maybe return an image. So how do we do new image? Is that a function? Yeah, it is. With the size here of the bounds, yeah. That's fine. Image, image, bound, wait. Canvas bounds dot width, canvas bounds dot height. This should give us the image that we can then return. Let. We also need the graphics context, so let g equals image.createGraphics, get graphics. What's the function? There, get context, 2D. Get context 2D. Does image not have that? We just have to say new canvas and whoops instead, right? No. HTML canvas. Element. Canvas is for drawing. Okay. Expected 0 arguments. Okay. Image.width equals that one, and image.height equals that one. then these should draw on G instead. What? G. And it's not null. And then down here we can draw ctx.drawImage. And does this take a mode? This can take image, right? And 0.0. What are the overloads? It does not seem like it takes a mode. Okay. A bad constructor. Aha. Boom. Is it working? It's drawing something. Yeah, it seems to be working. So, okay. So what if I draw the same image again on top? Does it get brighter? No, it just overrides it, right? Yeah. If that's it, then it's really easy. Equals lighter. Right? That's it. That was not it. Oh, because it was already there. Yeah, obviously. So now we do need to clear it. But that is what I expected to see. We also have the trails back. Although, why are they persisting throughout? Oh, we're not clearing the other rectangles. G.clear. Wait, but we're making a new one though. Oh, because... What if we say clear here then? Does that make any difference? It's, well, it's white now. Before I do it. So fill rect. And then adding after that. No. Then scale the image down. And I guess we can do that simply by creating a new one. Well, let's get scaled down. Yeah. And we need to give it like a factor. Let's give it 1 and the image that we want to scale down. So let's say scale down here. Takes an image, which is some, well, it's, yeah, it is that one. And then it takes a number, degree. Is image not a canvas? Yeah, it is. Oh, it's an HTML canvas thing, okay. Okay. And then what we say is canvas.drawImage. We also need to make the, we need to halve it. Halve it? Halve it? Halve. Scale it down. To half its size. So ctx dot, well, we can create a new image that has half of the size. Here, image, this would be the original. Then we can say image is a new canvas with the original dot width divided by 2, the original dot height divided by 2. Then we need to get the context, and then we need to draw on this G the original on 0, 0, but where the original width and height are mapped to the new ones that are half as big. 0, 0, or height 2, orange height divided by 2, and this is the width. So now I think we have an image that is half the size. If the degree is less than 0 or equal to 0, we don't do anything. So this is half of the size. Yeah, so what happens if I draw this scaled up on CTX? Dot draw image with the new image, the IMG, on 0, 0, but scaling them up this way means the canvas bounds. No, it's a smaller size, so it's actually this one and this one to the 0, 0 bounds dot width and canvas bounds dot height. We're not actually drawing the original anymore, which is bad. We should draw the original also. So let's just take these and draw the original image on top. Are they blurred? They might be a little bit blurred. So let's say that here we call scale down with the new image with the degree -1. What happens if we do 2 instead? It should blur them, and then, I mean, we're drawing more and more pictures on top. Oh, it is blurring them. That does look like a little bit of a bloom effect. Let's do 3. They're starting to glow a lot more. Right? Do you see that? I mean, that's so cool. They're glowing, guys. Let's get them tails back. The slow part is how you deal with the JS list. Yeah, apparently. Apparently it is. Boom! Wow, guys. This is so pretty. I love it. Feels like 2020 is finally over. All right, I should have done this as the New Year's stream.